Thank you for downloading this podcast from Talk Radio 702 and 567 Cape Talk. For more podcasts and more information on your number one news and talk station, please visit 702.co.za or capetalk.co.za.
Use your rights. Act responsibly. Lead SA. The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
25 minutes to 10 o'clock. You can call us as of now on 021 446 0567 011 883 0702. Chris is joining us from the UK, the Naked Scientist. Good morning, Chris.
From the rainy UK.
Oh,
it's terrible. I need some of your sunshine. I tell you, this is getting me down in a big way.
It makes me... okay, I'm going to shush because I was about to complain about the cold spell and the snow that we experienced in the last couple of days, but it has cleared so nicely. It is nice and sunny, but I understand in Cape Town, if it's of any comfort to you, Cape Town is also experiencing dreadful weather. Sorry, we're in Joburg, guys.
But it's winter time. It's supposed to happen. This is supposed to be summer. I was talking to my friends in Sydney at the ABC last night, and ironically, at 6 o'clock in the morning in Sydney, the weather and the temperature was warmer and sunnier than it is here in midsummer, and it's their winter, of course. So, Olympics, bit of a washout by the look of things. Oh dear.
Oh no, in fact I was just about to ask you then, Chris, how's Olympic fever?
Oh, well, it's reaching fever pitch. Everyone's getting very excited. So I just hope that this clears up, because it'll be so embarrassing, because all the stereotypes about British weather are going to be manifest during the Olympics if this doesn't improve. Because it is raining every day. Every single day it's cloudy and it rains. It's unbelievable. We're so depressed.
Shame. I wish I could give you a hug. Sorry about that.
Oh, please do.
Okay, Chris, let's start with this story. I wonder if Marva shared it with you. It's in the Star newspaper this morning, of a little baby whose brain grew outside his head, and the condition called anencephaly. Is that how you say it? What is it, and how does it happen?
Yes, this is anencephaly, you're right, or anencephaly. That's absolutely spot on for pronunciation. This is what we call a neural tube defect, and it's thankfully relatively uncommon. Less than 1%, far less than 1% of the majority of births are affected. So in other words, I'll try and put that more clearly. Fewer than 1% of births are affected. And what actually happens is that it's a developmental problem. When you have a developing baby, in the first month of a baby's life, after the sperm and egg fuse, they make a ball of cells, and that ball of cells then forms a flat dish or plate of cells, and within that plate of cells, at a certain point in development, suddenly a sort of rod-like structure called a notochord grows from one end of the plate to the other end of the plate, and that's the future spinal column, and that notochord induces the cells above it to proliferate and then form another tube, and that is the neural tube, and that is the spinal cord. And at one end of that tube, normally some bubbles or dilatations appear, and those are going to be the forebrain, the bit at the top of your head, then the midbrain, the bit that links the two hemispheres of your brain together, and then the hindbrain, the bit that controls bodily function and coordinates movements, and then the spinal cord is attached to it. Now, for some reason, and one thing that's been linked to this is a deficiency of the B vitamin folic acid. If you have too little folic acid and some other rarer things, diabetes can also be linked to this, heavy metal poisoning can also be linked to this. There's a weak association with heredity, so sometimes you see a person who's had this in their family, but there are very few genes which have actually been shown to or proved to be absolutely causal for this. In those instances, for some reason, the neural tube, instead of closing at both ends, it remains open. And one manifestation of this is a condition called spina bifida, which is at the bottom end of the spinal cord. The tube fails to close, and it can cause sometimes no problems, sometimes quite dramatic problems. When this happens at the head end of the spinal cord, then it can trigger this condition anencephaly. And what happens is that instead of the vault of the skull and the brain forming properly, they actually have no skull vault. The nervous system sort of herniates out at the back of the head, where the brain would normally be constrained by the skull. That tissue then degenerates, and so a baby can be born which has all of its normal craniofacial structures from about the eyebrows down, but then from the eyebrows upwards, there's no skull vault, there's no proper forebrain, and there's just normally a midbrain and hindbrain sitting there. So these individuals can function in the sense that they have vegetative function. The brain stem that controls respiration and heart rate and blood pressure can be functional. So they can be alive in the sense that they are viable in certain contexts, but they have no consciousness, they can't feel any pain, and they'll never improve. And of course they haven't got the whole of the back of their head, and so it's a very dramatic and very sad condition because there's not much we can do about it. Luckily it can be spotted early. There are some biochemical tests that you can do for a chemical called alpha-fetoprotein, which is produced when the nervous system is developing, and you can use that to pick up people at risk of the condition, and then ultrasound scanning can show doctors that this is happening, and they can then warn the parents, and under certain circumstances pregnancies can be terminated.
All right, I think you've answered a whole lot of questions about how it's possible for the baby to still be alive and so on. But what I do want to know, it does sound as though the final prognosis for the patient is death. Do we know then how long can they live for? Are there people who have lived, a couple of years, a couple of months with this, or is death almost immediate?
I don't know the answer to that question. I know that a high fraction are stillborn. In other words, they're just inviable. So as soon as they're disconnected from mum via their umbilical cord, they just don't have enough neural tissue to control the right physiological function. In terms of long-term survival, I don't know the answer to that, and I think the odds are pretty grim, actually.
Yeah, sounds like it. Okay, let's go straight to the lines and go to Ian in Randburg. Good morning.
Hi there, Edie. Good morning, Professor, Doctor, Chris. Last week you spoke about electric motor cars, and there's always this problem about recharging of the power source. Now, in a combustion engine, a car runs and an alternator continuously recharges the battery. Why is it not possible to design a vehicle which runs off a battery and electric power, where the wheels act as the alternator or generator, which continuously then recharges the power source?
Hi, Ian. Okay, there's really two considerations here. The first is that in order for the world to survive, there is the law of thermodynamics. Effectively, there's no such thing as a free lunch. So if you need energy to make your car go along, if you recapture that energy via an alternator connected to the wheels, then you're taking energy out of the car to put back into the battery, and that's going to slow the car down. In much the same way that pushing against the air will slow the car down. And that's why you actually need to keep putting energy into the car to keep it moving. So if you extract energy from a system to put it back into a battery, then actually you've suffered a loss, because no system is very efficient, is 100% efficient. So you'll extract your energy back from the car and put it back in the battery, the car will stop, and you'll actually have less energy back in the battery than you started with, because you'll have lost some as heat. So in other words, it's no such thing as a free lunch. That's the first point. And the second point is that no system is efficient enough to recapture all the energy. What people are doing, though, is something called regenerative braking. And instead of you wearing out your brake pads on your cars or vehicles, what you can do is to connect a vehicle to a load. So you have a dynamo on the car, and this is how some of these hybrid cars work. So you have a dynamo or an alternator, and as the car starts to slow down, it slows down by generating electricity and putting that into a large storage device like a giant capacitor. And because you are generating electricity out of the car's motion, the car is effectively being braked by this electrical generation, because you're pulling energy out of the car, kinetic energy, and putting it into an alternator. And because you've put the energy that you generate back into a battery, you can then use that electricity to get the car going again. And a lot of the fuel that gets burned by normal combustion vehicles is used in accelerating away from a standstill. So you can actually offset a lot of the load on the engine, you can reduce the fuel burn, which is how these hybrid cars achieve very good miles per gallon rates.
Let's go to Michael in Pretoria. Good morning.
Thank you, lady, for taking my call.
Sure.
I want to find out, how do scientists tell with precision that the planet they're looking at is either a rocky planet, hot Jupiter, or ice-cold planet when they're checking it from a distance? How do they know?
All right.
A good question, Michael. Now, South Africa is about to build one of the world's most powerful telescopes, and there's a lot of very good space scientists in South Africa, so I have to be careful what I say here and make sure I get it right. So if I do get it wrong, please correct me. The answer to this is, at the moment, we're only really very good at spotting these hot Jupiter planets, big ones. And that's because we're looking, using a range of techniques, chiefly, though, at the way that they make the light from the star they're orbiting wiggle. And this is because when an object, a big object, goes in front of a star and then behind a star, the star moves a little bit under gravity towards the object. And that means that the light coming from the star is either stretched out or squeezed a little bit, red or blue shifted. And that changes the spectrum of the star very slightly. And you can see what sort of period it does it with. And this means you can work out, based on the colour of the star, how big the star is, how big the object therefore must be, and you can infer its mass. Now, in more recent years, what people have been doing is, with more advanced telescope techniques and astronomy, they're able to actually use the light from the star coming through the atmosphere of the orbiting body. And when light comes through an object, say a gas, the elements in that gas will absorb some of the energy in the light, and they then re-radiate the energy at the same wavelength. So any element has a unique pattern of absorption and emission of light. So you can look for holes in the spectrum of light coming to you, and you can work out what must be in the way of that light. And if you know what the planet is doing around the star, you can see these gaps appearing and disappearing, and this tells you there must be something with an atmosphere composed of X in orbit around this star, because we see these absorption patterns turning up. So people are now beginning to use starlight coming through the atmosphere of these bodies to work out what's in them. And you can do that for water, because water and hydrogen has a specific absorption pattern, so you can begin to spot it. And people have spotted at least one body I'm aware of, absolutely huge, which would be oceans hundreds of miles deep on its surface if it is liquid water. Incredible.
Thank you for the question, Martin. Let's go to Chichi in Reimsach.
Hi, Rudy. Hi, the Naked Scientist. I wanted to know, if you close your left eye and you look at, for example, a clock on the wall, it would be in a specific position. And then if you close your right eye and you look at the exact same clock on the wall, it looks like it might have shifted either a little bit more to the left or to the right. What is the explanation for that? I'll listen on the radio. Thank you.
Yes, what a lovely question.
Yep.
And it sort of has some relevance to the astronomy we were just talking about, because this is called parallax. And if you want to work out how far away something is, you can do that very experiment. Because if you look at something with your right eye, because your right eye is a little bit off to one side of your left eye, when you stare at something, then your right eye is looking at one angle, your left eye is looking at another angle to see that object. And so if you look with one eye or the other eye, the object appears to move, because you're bringing two images of the object into your brain to generate stereo vision. And astronomers actually use this same trick to work out how far away certain things are. For instance, about several hundred years ago, Romer, who was an astronomer, was working out how far it is to Jupiter, for example. So what you can do is you wait till the Earth is on one side of its orbit, as far as it can be from Jupiter, and you look at the angle to Jupiter. You then wait till the Earth is on the opposite side of its orbit, and you make the measurements again, and this gives you an idea, based on how much the object appears to move in the sky, how far away it is, and that's called parallax. And so basically it's because your two eyes are a certain distance apart, and so when one eye is looking at the object, then in order to actually see it in stereo vision, if you shut the other eye, it appears to move, because you actually get forming two slightly different images and then superimposing them in your brain.
Let's go to Ipileng in Harties. Good morning.
Hi. I have a question about babies. When you hold a baby, they seem to be happier when you're standing up. Why is that?
Happier?
Yeah, like they cry less.
Yes, this is what you sort of have to keep bouncing them, because as soon as you sort of put them still, then they immediately start crying, don't they? I wonder if this is because when you've got them standing up, because I know my kids are like this. They're a bit bigger now, they're a bit hard to sort of do this with, but when you sort of stand them up and bounce them around, you're more likely to be looking at them, and I think that they like that visual contact, and the fact that they're looking at you, but also they can look round the room. If you've got them laying down, they can only see the ceiling, which tends to be a bit boring.
Demanding little breaths.
Oh, they're lovely, really.
They are, I'm sure. Francois in Silverton, hi.
Good morning. I'd just like to know what components in our gene system, human beings, specifically, is different from the animal kingdom regarding facial features. Why do impalas look exactly the same, but yet on human beings, we all look different?
I've wondered that when I'm fascinated by lions. I'm always watching them.
Yeah. Why they look exactly the same, but yet we look all different? What?
Well, you think they look all the same, but they would disagree with you.
Really?
And yeah, and birds are the same. Birds can discriminate facial features of humans. They can also discriminate each other. Now, you think, well, a bird looks much like another bird, but actually they do look quite different.
Wow.
And Maori wrasse, fish, these Napoleon wrasse, they're beautiful. They have these interesting facial patterns around their eyes and lips, and it looks like the Maoris where Maori tattoos are done on the face. The fish have a similar sort of patterning, and those patterns, whilst from a distance look the same regardless of whichever fish you look at, if you look very closely you see actually they are very different, and the fish can recognise each other based on those patterns. So I think it's more that we are not tuned into what to look for. Also, bear in mind that some animals don't live in just a visual world. We're a very visually dominated animal. More than a third of our brain power is devoted just to decoding what we see and what we're looking at. But other animals live in a world which is dominated by other senses, or massively, massively boosted by other senses. So, especially in the case of impala, you say, well, their hearing is fantastic and their sense of smell is fantastic. And so all of these additional factors will add up to the picture that they make of the world, or they build of the world. We live in a world which is dominated by vision, with smell and sound at the periphery. They live in a world where smell and sound are very central, with a bit of vision on top. So I think that when you bring all those things together, they do look different to each other, and then you superimpose these other extraordinarily more high-resolution senses they have, then they will tell you that they look very different. And if you think about it, in Antarctica, when the penguins come back after going out fishing, there will be thousands and thousands and thousands of baby penguins on that ice, and they find their parents, and their parents find them. And they all look pretty similar to us, but when you look at it in terms of the way they smell, the way they sound, they're very distinct to their parents.
I've often wondered, in the pride of lions, how the little cubs know who's mummy and not auntie, and they seem to just always target the right person. They know who daddy is.
Almost certainly by smell, pretty much. I mean, lions have very good vision. The cat family have excellent vision, but they also have an excellent olfactory system. And the smell of mum when they're born is strongly imprinted on them, and the smell of the baby is strongly imprinted on the mum, and the two bond. And so they will always go around looking for that particular smell.
Well, we have to wrap up the conversation about lions, because once I get started, Chris, I just get so excited like a little girl. I love them. Okay, let's go to Yaku in Rustenburg. Hi.
Hi, Reedy. Hi, Nick. My question is to do with genetic engineering. Have scientists discovered intact genetic material, such as in animals caught in amber, in fossilized amber, you know, like insects and scorpions and frogs, such that they could clone that genetic material and recreate those animals, and not only those ancient animals or ancient species, but even a more recent species such as the dodo. Is that possible? That's my question. Thank you.
It's a very good question, and of course it's the sort of thing that Michael Crichton was writing about in his book Jurassic Park, because the whole story of Jurassic Park was that insects which had preyed on dinosaurs, and specifically blood-sucking insects, had preyed on dinosaurs and then got stuck in some amber, and the DNA from the dinosaur was therefore lurking inside the gut of the insect and could in some way be cloned back out. The insects in amber are millions of years old, and DNA is a very robust molecule, but we don't think that it would survive sufficiently intact, at least with our present technology, for us to get any decent dinosaur DNA out. That said, techniques are getting a lot better, and we now are in the position where we have the complete genome, for example, of Neanderthals. Now, Neanderthals disappeared around about 20 to 24,000 years ago. Their last sort of vestige was probably in Gibraltar on the south of Spain, and that was about 24 to 20,000 years ago. And we've now got a complete genome sequence for Neanderthals based on finding fossilized specimens or buried bone specimens and then extracting DNA from it. And the DNA is all fragmented and broken up. But what you do is to keep reading enough times, and by looking at all the little pieces and feeding the sequence of all the little pieces into a computer, the computer can eventually work out how they must all line up. It does the jigsaw puzzle rebuilding for you. And so now they have the complete Neanderthal genome. If you'd said that this would be possible 10 years ago, people would say, that's an extraordinary claim, I don't believe it. And yet here we are. People are also beginning to reconstruct the genome of the mammoth, because we have mammoths frozen in the permafrost in Siberia. And the DNA, again, is quite degraded, but with modern technology it's possible to read a lot of it, so we can understand how mammoths came about, how they're related to other species, such as elephants, for example. It's a big jump, though, to go from the DNA sequence to recreating an animal that's extinct. Because what you don't have, although you've got the genetic code, you don't have a viable cell to put that DNA into, which has all the right chemical environments inside the cell to kickstart that DNA and then start the cell dividing. So that's a challenge, and we're not there yet.
Chris, last question. Does your shoe size change when you gain or lose weight? It's an SMS.
I would have thought not terribly much. Things like your hands and feet, if you just gain weight the normal way, and by that I mean you haven't got a pathological reason for growing, such as having acromegaly, too much growth hormone, for example, then certain parts of your body don't put on weight, because you put on weight where you have distributions of adipose or fat tissue, and they're distributed in certain places. Your hands and feet are protected by special fat pads that soak up impact, and therefore you have a certain amount of fat they will accommodate, and you don't tend to put too much extra fat there. You put a bit, but I wouldn't have thought terribly much. So I don't think shoe size gets enormously bigger if you put on a lot of weight, not like your stomach, for example, which can swell quite significantly.
We know all about
if you eat
that.
a lot of very good food.
Thanks, Chris. Survive the weather.
Pleasure.
We'll talk to you next week.
Take care. Bye-bye.
Bye-bye. And this conversation will be available for you as a podcast later this afternoon.